So, so from the previous part, right, we kind of uh, concluded, the previous part was concluded with one observation, right? So when we adapt a large language model to the vision task through a shallow alignment method, there is a possibility that the large language model might lose its natural language ingestion abilities, right? So that's what we understood from the previous thing, right? So that's where the CogVLM is trying to come in and tries to address that limitation. The question with respect to CogVLM is right that what CogVLM is trying to address is right. So can the NLP proficiency of a large language model be maintained while enhancing it with superior visual understanding capabilities? So what CogVLM is trying to preserve is the language abilities what it has acquired, what to preserve it when it got adapted to the visual language class, right? So, so basically, what actually it introduces, that is the CogVLM. So if you look into to the CogVLM structure, right, it introduces a QKV matrix. This is one transformer block inside the LLM. You can, okay, you can think. So it introduces image features, like it takes image features, passes through additional QKV matrices, as well as the additional FFM layers in the transformer block, right? So, so basically, in a way, in each transformer layer, the image features in the sequence uses a new QKV matrix and additional MLP layer with the text features. So, due to this, visual export module due to the visual export module, right? The number of parameters doubles up, but the interesting fact is the flops remain same. That's what they claim, right? But due to this, right? Since all the parameters in the original language model are fixed, right? So because we are not going to change this QKV and this layer norm and whatever the pre-trained weights were there associated with the LLM, but they were untouched. So the additional image knowledge is fused through a QKV and FFN layers, right? So since we are not touching, we are not changing the original language model weights, so the performance will not degrade if the input doesn't contain any image, right? So, but where this inspiration came from, like what are the earlier works motivated this CogVLM, right? So there are two works basically inspired the CogVLM, pre-tuning as well as the LoRa, right? So in the pre-tuning, what it does, so it in pre-tuning, right? So pre-tuning basically learns a task-specific prefix embedding, right, in the input, while the LoRa adapts the model weights in each layer via LoRa matrix, right, approximation. As a result, LoRa performs better and stable. So the similar thing can be exist in VLM as well, right? Because in CogVLM, right, it uses both. So what it does, it tries to use a shallow alignment method, which behaves like a the prefix embedding learner, that is a pre-tuning, as well as it introduces a trainable visual export in the each transformer block in the LLM. So because of that one, it is not kind of altering the pre-trained words of the original language model, right? So additional knowledge that is required to solve the vision task is incorporated in the form of a visual export. So that's where, in a way, on a higher level, we can think of CogVLM is basically bringing both p-tuning in the form of shallow alignment method and LoRa kind of approach through a trainable visual expert. But trainable visual expert is not a low rank approximation. You can think of it as a full rank. Sure, you can. Okay. So these are the basically. So what in this part, what we have seen, what question it tries to address, and what are the main components it is trying to address, and what are the inspirations for this work. Okay, like a p-tuning and LoRa.